Hello, everyone. Today, let's explore a science fiction scenario that is terrifying, yet based entirely on real data. What would happen if a tiny black hole, just the size of a grape, silently approached our Earth? It sounds like a Hollywood movie, right? But don't be so quick to dismiss it. Scientists have meticulously calculated and even simulated the many scenarios that could play out. We will dive deep into these cosmic secrets, from the origin of this black hole to the catastrophic consequences, and perhaps the bizarre opportunity for our home planet. Let's begin this unexpected journey. Have you ever imagined a black hole approaching Earth? It's a picture of pure chaos. You might think this is just a crazy idea, but science shows this possibility is not zero. Researchers have used supercomputers to simulate what would happen if a tiny black hole with the mass of a mountain but the size of a grape wandered into our solar system. To understand this, we must travel to the distant edges of our solar system, past the orbit of Pluto, through the Kuiper Belt, and out to the Oort cloud. Here, icy asteroids are moving in strange, erratic orbits, as if being pulled by an invisible hand. Currently, scientists have two main theories for this. The first is Planet 9, the idea that a planet 10 times the mass of Earth is lurking out there, remotely controlling these icy objects. But what's strange is, with modern technology, we can see galaxies billions of light years away, yet we can't find a massive object in our own backyard. That's when the second theory emerges, and it's even heavier. Perhaps that mysterious object isn't a planet, but a tiny black hole. Yes, you heard that right. A black hole the size of a grape. This isn't a joke. It's the result of serious calculations from Nobel Prize-winning teams. The idea dates back to the infancy of the universe, just after the Big Bang, when all matter was compressed like a thick soup. In some regions, the density was so high that matter collapsed directly into primordial black holes, totally different from normal black holes formed from the death of giant stars. These primordial black holes are much lighter, maybe only the mass of a mountain, but squeezed into the volume of a grape. If one of them happened to wander into the edge of our solar system, its incredible density and gravity could absolutely remotely control those asteroids in the Oort cloud. Scientists from the University of Barcelona and other institutions have used data from the Hubble and Gaia telescopes to support this, and they estimate that 1,000 to 10,000 such black holes are wandering the Milky Way. The probability of one approaching our solar system is incredibly low, about 1 in a million billion, but the universe is vast, and its history is long. Nothing is impossible. Now imagine the worst-case scenario. This tiny black hole approaches Earth. Simulations show, first, it would cause horrific gravitational disturbances. Its gravity would pull and tear at space, creating powerful tidal effects. The oceans of Earth would swell into waves hundreds of meters high, sweeping everything away. Mountains could crack, and the atmosphere would be distorted, creating massive magnetic storms that disrupt all electronics. But that's just the beginning. As the black hole gets closer, just a few thousand kilometers away, the event horizon, its point of no return, would become apparent. Anything that crosses it is swallowed forever, and time itself is distorted. To an outside observer, you would see someone falling in slow down until they appear to freeze at the horizon. But from the perspective of the person falling, everything seems null, except the universe around them is being stretched into cosmic spaghetti, or spaghettification. This is an extreme tidal effect. The gravity is stronger on the part of you closer to the black hole. Your head would be pulled harder than your feet, stretching you into a long noodle before you even reach the center. For Earth, the entire planet would be stretched this way. Continents would crack, the core would erupt, and finally, we would be consumed. No chance of survival. Total annihilation. But the simulations don't stop there. There's another scenario where the black hole doesn't swallow Earth directly, but grazes us. In this case, part of the planet could be frozen in time. The regions it passes over would slow down infinitely, while the rest of the planet continues. The result? Earth would be torn in two. One half would be trapped forever at the event horizon, while the other half is flung away. The people on the trapped half would experience time stopping. They would live forever in that final moment. Immortal, but imprisoned in another dimension. It is perhaps the most terrifying form of immortality. However, if Earth is lucky, the black hole might miss us and go straight for the sun. The battle between the sun and the black hole would begin, and the sun would inevitably lose. The black hole would consume our star, creating a massive burst of energy, but Earth might be temporarily saved. The black hole's gravity would disrupt our orbit, ejecting us from the solar system like a kicked ball, beginning a lonely, cold journey as a rogue planet through the Milky Way. Although Earth's surface would quickly freeze, we wouldn't die immediately. Earth's core, with its molten iron, would stay hot, 4,000 to 6,800 degrees Celsius, for about 100 billion years. Humanity could dig deep, building massive underground cities. The atmosphere would freeze into snow and ice on the surface, which we could mine for oxygen and water, creating a sustainable underground society. But the bigger question is, after generations of living underground, what would humans evolve into? We'd likely develop pale skin, slender bodies to adapt to the tight spaces, and an extreme tolerance for the cold. Or if our journey takes us near another star system, we might hope to be captured in a new orbit, restoring life to the surface. If not, humanity would vanish, leaving only a frozen, dark planet, drifting forever. All of these scenarios are based on simulations from top physicists like Avi Loeb's team at Harvard, who published research on primordial black holes in 2025. They're using data from the James Webb Space Telescope to search for them. Of course, the actual probability of this happening is extremely, extremely low. But it's a powerful reminder of how fragile our position in the universe truly is. Black holes aren't just movie monsters. They are real relics of the Big Bang, and they might be lingering closer than we think. See you all in the next video. Remember to like and share, and let's keep exploring the mysteries of the universe together.